we have a really cool subject here. We're going to talk about how energy storage works, common misconceptions about it, types of energy storage, the environmental benefits, incentives, and a ton more helpful things to know about this technology. It really is very, very cool and fast moving. So I do want to start off by pointing out a lot of the misconceptions around this technology. And we kind of boiled it down as a company to the top three that we get quite often in terms of questions we get from customers or potential customers. A lot of just discussions around solar in general in the industry and how battery storage works. So the first misconception that is so common is that, as long as the sun is shining, I'll have power. Well, not quite. Your grid-tied solar system is designed to actually shut down when the grid goes down. And that's actually, in a way, a law because it's about safety. So it's a very good reason. What happens typically when there's an outage, especially caused by like an obstruction or something like that, a lineman will come out to work on it, to repair it, right? And if solar energy, that's producing electricity is feeding back into the grid while the wires are being repaired on, it could cause serious injury or even death for that lineman. And that's a risk that in this world we cannot take ever. So there's a really good reason why that power cannot be accessible when things are down in that way. So that's a really common one. We can definitely address that in our question segment a little bit more in depth, but that's definitely a notable one. So the second one there is, there's a transfer switch for, optional off-grid usage that I can flip anytime. So this is most certainly not the case. Most inverters are grid connected. That's just the most common type of installation that has to do with, solar inverters and batteries. And so with that, the inverter senses like grid differences with frequencies and voltages, and it tells it to power up or shut down. The problem with that, though, is that the system can't throttle how much power is coming in. And so if the system doesn't have that type of insight, it can't actually regulate what it can handle. So that can really lead to a very dangerous outcome. It can also be really damaging to the system. And that's another thing we can address more in depth in our discussion. But yeah, that's definitely a very, very common misconception that we have, and we get from a lot of folks. And I'm just admitting a few more folks here. And then, so our third most common misconception is I can run a generator and my solar system at the same time. And the reason behind that is that it could completely fry the generator because, again, there's that regulation issue. So that's another really huge misconception, and something to note, especially in terms of safety and when you are investigating generators and things like that. Sorry, I was just admitting some folks while I was saying that. So yeah, these are things to think about as we move forward in this presentation. And we're going to address a lot of these parts too in our discussion and moving forward with what we're learning here throughout the presentation. So moving on to different types of, if my screen can, perfect. So there are a few different options to have assurance of power. And those main options really boil down to these three key functionalities. So battery backup. From an environmental and economic standpoint, it makes a whole lot of sense to tie your solar array system to the grid. It allows for the usage of, very cheap or free access to energy during the nighttime and it allows for, other customers drawing from the grid to make use of excess clean energy during the day. So if you really think about battery backup, it's very efficient, it's very balanced, and it's something that's becoming ever more popular. Moving forward to self-consumption mode. This takes place when the loads are drawn the loads drawn from the home are present at the same time that the solar energy is being produced. This energy is not stored for later use. It's a good thing to remember, because you don't want to rely on something that's not necessarily there. If there is more power needed for loads, more than what the actual solar is producing and can contribute, that excess power will be drawn from the utility. And that's where you would either, if you're taking part in net metering, you'd get the credits back, or what have you. Something we'll definitely talk about as well. And then moving on to the time of use mode. Now, this mode intentionally does not draw power during energy peaks, which is way more, it's very sustainable for the grid, for the economy, for your own pocket, and for the environment as well. Because if you really think about it, and this is a really good, if you walk away with anything today, this is a good thing to remember in general with drawing power from the grid. The most dirty energy that you can be utilizing and purchasing is going to be energy that is during peak, when everyone is drawing from the grid. So that can be offset with the time of use mode, and that is something else we can definitely delve into. But all of these functions play into a very, very healthy load distribution, and it will all, each one will be used dependent on what your needs are as a household or a facility that is utilizing these systems. So that's something to keep in mind too, that these all work really, really well when applied in a very appropriate manner. I'm going to hand it off to Eric to go through this diagram right here.
Awesome, thanks, Jane. So I think a good transition from talking about functionalities of the battery, the three main functions, is now discussing the flow of electricity in real time with a grid-tied solar system, as well as a battery backup integrated with that given system. So this is a great visual that you guys are all looking at, and I guess we can start from the very top. Let's start from the sun. So the sun hits the solar panels. Those solar panels are generating DC power. That power then goes into an inverter. If we're following that yellow dotted line, the electricity is going into the inverter, and then that inverter creates AC power that can be used at the house. So immediately, once the solar panels generate the electricity and that electricity gets converted to AC power, that electricity wants to immediately service any of your home's electric needs. So your refrigerator's on, any lights that are on, it wants to service your home's electric needs right away. Now, if there's excess electricity being generated, typically without a battery, that excess electricity would actually go back out to the grid, and you would be selling the power to the grid. But with a battery system, if you have one, that excess electricity can get stored into the battery. So once that battery is at a full charge, the last resort for that excess electricity, where it would go is it would go back out to the grid, and you'd be net metering your solar power, and you'd be selling your power to the grid just like you normally were going to do. So that's what happens during the daytime. And at night, when the solar panels aren't generating any power at night, what will happen is, instead of first pulling power from the grid, you would actually start pulling power from the battery. And you would continue to pull power from that battery until that battery gets discharged, at which point then you would start pulling power from the grid. So having a solar system that's grid tied, that also has the integration of a battery system, will actually allow you to function kind of like an off-grid system with the very backup of using the grid if you need to. And what I'm talking about right now is self-consumption. One of those functionalities of the battery that Jane mentioned was self-consuming the power. And that process I just outlined and it illustrated was doing just that, is self-consuming more of the solar power that's being generated. And it's extremely beneficial to do this, because here in New Hampshire, when solar customers net meter and sell their power to the grid, they are selling their power to the utility at a slightly lower cost than the cost in which they have to buy electricity back from the utility. So if you can store the excess electricity in the battery and use it later, keep that electricity on site and keep it local, you, the customer, will actually be seeing a higher value for the solar power because you're self-consuming it and you're not selling as much back out to the grid. So I think that's a really key benefit of having a battery, is not only obviously having it as a backup for power outages, but using that battery on a daily basis when you are grid connected and using it for self-consumption has a lot of benefits. So this next slide, we are going to be talking about are the incentives. Well, for a battery, there really is only one incentive, I should say, and that is just like with solar panels. If you were to purchase a solar array that's grid connected, solar panels are eligible for the investment tax credit of 26% of the total system cost. And batteries are also eligible for that investment tax credit. So that is a great thing to have, because it really makes the economics of a battery, it makes it more viable for the end user. And you can kind of really see the cost of a battery being justified versus spending money on a generator.
All right, thanks for that, Eric. Yeah, so there's a lot of reasons people go solar, whether that's for economic reasons, so interested in the technology, environmental benefits, and that kind of thing. But a really big underlying reason is just that. It is the environmental benefits that come along with it. And I think it really just, it speaks volumes as to how incredibly cutting edge this technology is becoming, and how that can really offset our kind of older, more out of date energy production methods. So, there really is, solar and energy storage, especially, that combination is incredibly efficient. It truly is an environmentally sustainable climate solution. And the best part about all of this is that your solar energy production, or your just energy production in general, is as locally produced as your own roof or yard. It is within your control. It's your system. And I think that in terms of resilience and independence, is such an important aspect of being able to store this energy that you produce. So not only does it, sorry about that, not only does it alleviate the peak load from the power grid, which is a very, very great aspect of this, it really just reduces dependence on that non-renewable and limited resources fuel that we have been using for so long. And so that really does promote ecological benefits, and overall reliability on where we're getting our energy. So incentives, just as Eric was talking about, really do make this transition doable for every single one of us. It's important to really push for this, and it's just along the lines of where we're headed anyway. Within 5 years of now, in 2025, 25% of solar installations will be paired with an energy storage system. That's just the trajectory that we're working on and working with right now, which is really hopeful. I think that's a great push. So I think that there's a lot to be said about this, and we can always delve into this in a more deep, thorough way. But there are so many environmental benefits of this type of pairing, and especially with solar energy pairings with energy storage. So just something to think about and appreciate about how um, this technology is helping us move forward in that regard. And there you go. And Eric?
All right, thanks, Jane. So we've been talking about batteries all this time, and now we're at the point of letting you all know what type of battery Granite State Solar offers. We offer the Tesla Powerwall. We're super excited to be able to offer this battery to you guys. We think it's an excellent battery. It's warranted for 10 years, and it has a battery chemistry of a lithium-ion based. And one of these Powerwalls, which is what you see here, can give you 13.5 kilowatt hours of storage capacity with a continuous power output of 5 kilowatts. Now, these specs are really important to know and to think about, because when we talk to customers on individual level, we really need to ask them questions about what their goals and objectives are of getting out of what they're trying to get out of a battery. You know, if they're trying to run their whole house on a battery during a power outage, we need to know that, and we need to then size that battery appropriately, so they're not calling us and saying that they're without power because there's not enough storage. So one of these batteries can give you a backup power for essential loads during peak periods of power outages. So what I mean by that is essential loads is most people want to have their well pump on for running water. They want to have domestic hot water. They want to have their refrigerator and their freezer, all of their goods stay cold. They want to have some outlets, maybe some lights. They want to maybe have their internet stay operational, so a modem and router connected to the battery, you know. But if you're looking to do your whole home application, that's fine, we can do that. But we need to then daisy chain these batteries together. And that's what's really cool about the Tesla Powerwall, is that you can link multiple batteries together. So instead of having 13.5 kilowatt hours of capacity, you can double that and have 27 kilowatt hours, so on and so forth. So one of these batteries, which is what you see here, the height of one of these is 45 inches. They're 30 inches wide, and the depth of them are about 6 inches. They can actually be mounted on the wall, or they can be mounted on the floor. It's also good to know that the location of these batteries, we need them to be in an area that doesn't get below freezing. So we can't put them in a garage that's not heated. The best place for a battery is going to be for the basement. You know, most people's basements, a poured foundation basement, concrete foundation typically maintains about a 50-degree temperature in the wintertime, especially if you have some type of residual heat source down there, such as a boiler or a furnace. So that's the optimal place for this battery. But you can also install the battery in the living space too, if you wanted. You know, some people really like the look of these batteries, and they don't mind having it be on a wall on the first floor of their house. But we do want that battery typically in an area that's next to the main electric panel for the ease of installation. You know, the cost of one of these batteries for a traditional standard installation that's relatively close to your main electric panel is going to be between $13,000 and $15,000 before your 26% tax credit is applied. So once you apply that incentive of the investment tax credit, you're really netting out at about $10,000. The weight of one of these, they are pretty heavy. They're about 251 pounds for one battery. So, all of these specs are something to, keep in mind and think about in terms of where, if you guys are thinking about purchasing one of these, where is going to be the best spot for one of them. And I think typically we're finding that the basement's going to be the best because, number one, it's close to your main electric panel usually, and number two, the temperature really doesn't get below freezing typically down there in the winter.
Thanks so much for that. So what I'm about to mention is not much different from what Eric has already started to point out regarding the Tesla Powerwall. But I just want to say that, it really is our jobs as your consultants and as folks who are in your corner in terms of educating you on what your power needs are within your household or your facility that you're running, to really understand, what your goals are in terms of that independence. So, everyone has different needs. Everyone has a different, size family that's living with them, or entirely different functions that are needed. If you have a different business running out of a certain facility or that kind of thing. So those are going to be incredibly, different in terms of sizing, and we want to help you have that wiggle room and that independence. So, you could just be fine having a few, or, you can be comfortable having just a few appliances and things, your, necessities met during an outage, or you need a ton of power for whatever reason. It all depends on what is needed from your household, how much power you're gonna need to pull. So that, I just want to point out that really is our jobs here to help you kind of meet those standards that you have and meet those goals that you have in terms of having that resilience for, whatever may happen to the grid or anything like that. So yeah, I think that really covers it, and Eric did a great job mentioning that in regards to the Tesla Powerwall. And so we're going to kind of shift on into our more interactive portion of this, and we can take questions. And I just want to point out too that if you kind of slide down to the bottom of your screen, this little tab will pop up where it has participants, and then that box will show up, and you can go ahead and raise your hand, and I'll point you out, and then you can unmute and ask your question. You're also more than welcome to ask any questions or comments in the chat. So I'm just going to go back to this page where you're welcome to take a picture of this for contact information, but I'm going to go ahead and see what we have in the chat, which I already see is having some questions being put in there. So from Mike Brown, Mike says, can the battery be integrated into a solar system with an automatic standby generator?
Yep, it certainly can. That is definitely an option, and it's an option that I've talked about already with one of my customers. So if you already have an automatic transfer switch generator that turns on automatically, what we could do for you then is we would have to break up the certain circuits. So some circuits would be tied into the battery, and then the circuits that the battery couldn't handle would then be tied into your automatic transfer switch. Such as, I had one customer that wanted a potentially a hot tub connected to stay operational during a power outage. Obviously, that hot tub draws a lot of power, and you can't have that be connected to the battery. But then we switched over that circuit over to the generator. So yes, you can integrate an automatic transfer switch generator with a battery.
Thanks, Eric. So another question we had is from Taya. How long has Tesla offered this battery, and what is the cost of adding an additional battery at a future date?
Yep. So the Tesla Powerwall has been offered since October of 2016, and the cost of adding a second Powerwall down the road would not be the same as the initial cost, so it would be less. in terms of adding a second Powerwall later. I guess I would encourage you to try and purchase, if you're looking to get 2 or more batteries, and if your budget allows for it, try and get it done this year, because the 26% tax credit is going to be getting reduced to 22%. The year after that, it's down to 0 as it stands now. So, I think from a financial standpoint, and to get the best cost effectiveness out of this battery, you're going to want to try and get it done this year to reap the most out of that tax credit.
Mm-hmm. And a follow-up from Taya is, how smoothly is the transition phasing from battery to grid and back? They are concerned about the electronic damage spikes.
Yep. So typically with like an automatic transfer switch, there is an actual delay from when you lose power at the street to when your generator kicks on. The technology in the Powerwall is actually more seamless than that automatic transfer switch that comes with these generators. It actually happens basically instantaneously. So you will automatically, within a second, transition over to backup power. You probably won't even notice that the grid's down.
Great. And a question from Joe, how far down can the battery be drained?
With these lithium-ion batteries, you can discharge them all the way down. You can go from a full depth of discharge, so 100% down to 0%. You're not going to affect the battery whatsoever.
Right. And a follow-up from Joe, since your systems produce AC at the panel, do you need a charger to charge the battery and also an inverter to convert battery power back to AC?
Yep. So these batteries, the Tesla Powerwall is what's called AC coupled. So correct, Joe. The power going from the panels after it's past the inverter is in AC. That electricity will then get inverted to DC to go into the battery. And then when the electricity wants to get pulled out of the battery to feed the house, it gets converted to AC. So there is what's called a battery-based inverter that does that conversion from AC to DC and then DC to AC.
Great, thank you. And so we have a hand up from David, and I'm just going to unmute you real quick, and you can ask your question if you want to unmute yourself.
My question is, when we purchase a system, can additional panels be added later to my existing system to increase the collection capabilities?
You're talking about solar panels, David?
Yes.
Did we install the system?
Yeah, so if you install it and perhaps I build a barn later on my property after I install an initial system, is it possible for me to add additional panels to increase the collection capability of the solar power?
Yep, absolutely, no problem. Our systems are microinverter based, so there's an inverter on the back of each panel. So if you want to add panels later on, you won't have to be upgrading any of the existing equipment that we originally installed to install more panels. It's a plug and play system. If you want to add more panels later, you're just going to need another panel and another inverter, and that's it.
Okay, thank you.
Thank you, David. So there's a question from Paul here. Can it be configured to allow me to run a portable generator to recharge the battery?
No, nope. As it stands right now, the software for the Tesla Powerwall 2 does not allow for a generator to recharge the batteries. I believe Tesla is in the works of getting something like that to actually happen, where a generator could potentially recharge the battery if there is not enough solar power to recharge the battery. But right now, there is not a software update that is made for that to happen.
Okay.
Thanks for the question.
Yeah. Thank you, Sue.
Thank you.
So another question we got from Mike is, what is the price range for 1 and 2 battery systems? Or one?
Yep.
Yeah.
So for one, I'm not sure if Mike, you heard it when I mentioned it on that slide earlier. For one Powerwall, you're looking at between $13,000 and $15,000. And I say there's a range there because you can actually finance this battery through our partnered bank, the Vermont State Employee Credit Union. You can do so for through a 12-year loan at a fixed 3.9% interest rate. And a lot of people are actually, I'm finding, are going with that option because rather than, having an upfront investment of, $14,000, rather than shelling out that money right away, you can take out a loan, and you can find that monthly loan payment for the battery is only going to be about around $100, which is pretty reasonable. But if you are going to self-fund the project and not finance it through our partner bank, we don't pay loan origination fees to the bank to offer you that loan. So we can pass those savings along to the end customer, which is why it's a little bit less expensive upfront. The upfront cost is a little less expensive if you can self-fund it rather than financing it through our partnered bank. So just to reiterate, one Powerwall, you're looking at about 13 to 15,000, and then for two, you're looking at between 22 and 24,000.
Right. Thanks, Mike. Another question from Taya is, how many cycles are the batteries good for?
Yep. So Tesla on the data sheet for the Powerwall, they don't specify the amount of cycles that the battery is good for. They do mention that at year 10, the battery will have up to 70% of still usable capacity. So what I mean by that is right out of the gate, you have 13.5 kilowatt hours of storage capacity. And at year 10, Tesla claims that you will have still about 10 kilowatt hours of storage left. So if at year 10, you were to fully charge that battery up, instead of having 13 kilowatt hours of storage in that battery usable, you would have 10. So the battery over time does degrade just ever so slightly. Same with anything really else. Your boiler down in your basement, it loses efficiency over time. Many of you, if you have solar, know that solar panels degrade and lose their efficiency as they age. Same with the battery system.
Great. And the follow-up to that exact question was that it's assuming this is cycled every day.
Again, Tesla does not specify if the battery gets cycled every day. Will it have up to 70% of the usable capacity at year 10? All they say is that at year 10, 70% will still be left in the battery. What I will do for you is I will do some homework on my end, see if I can do a little bit more research and find out if there is in fact any limitations on the number of cycles this battery can handle. So I hope to get back to you.
Great, thanks, Eric. So another question here from Tom is, would you please repeat the cost of adding a Tesla Powerwall to a new system at the time of installation?
The cost of adding a Powerwall to a new solar installation?
I believe that is what this question is referring to, yes.
Okay, so yeah, regardless, if we're adding the Powerwall during the installation of solar panels, or if we're adding a Powerwall to an already existing solar system, the price of the Powerwall does not change. One Powerwall, again, will have a price range between 13 and 15,000.
Great. A question from Joe. Do you need permission from New Hampshire or Eversource to increase your system size?
Yep, you sure do. Eversource, if you're going to go with a battery system, there's an interconnection application, just like that gets submitted for a solar panel system. We will need to submit that interconnection application for you. That will notify the utility that you're adding a battery, and Eversource will account for the kilowatt of that battery in addition to the kilowatt of your solar system.
Great, thank you, Eric, and thank you, Joe. And then another one from Joe is, are there any New Hampshire rebates, credits, or grants available for the battery system?
No, as of right now, the only incentive available for a Powerwall or a battery is that 26% tax credit, as long as the system is grid tied.
Right on. Okay. And Mike Brown is asking, does New Hampshire have time of day pricing that could be used with this? Do we only do Tesla batteries?
So there is, as far as I know, there's no time of use rates currently in place here in New Hampshire. What I found to be very interesting is there's the potential for utilities to compensate customers who have batteries, in that the utility will actually discharge the electricity from the battery during times of peak demand. So peak demand is typically in the afternoon hours between, say, 3 and 6 p.m. when people start coming home from work. Everyone starts going home and start turning on lights and things like that. It's very costly for the utilities during this time of peak demand, and they are thinking about compensating customers who have batteries that are allowed to discharge their battery to the grid. They could potentially get paid for that electricity that they're providing to the utility.
Is the 26% savings designated for 2020 and will it extend to 2021?
So the 26% tax credit is good for if the battery gets installed in this calendar year. So you can claim the 26% tax credit so long as you have the battery installed and inspected and fully paid for before December 31st of 2020. If you get the battery installed in the following year, 2021, then you're going to be subject to the 22% tax credit.
Thank you, Eric, for all of your explanations. And yeah, we hope to hear from you. Always feel free to reach out to us via email or give us a call. We're always available to answer any questions you have. Thank you again. This was wonderful. And don't be shy to follow up. We're happy to help in any way, shape, or form.